In this video, I explain my solution to question 1 of homework 3. In the first part, we are asked to find the value of b so that this probability represents a probability mass function. Now, we know that for a probability mass function, the summation over k is equal to 1. We substitute for this probability of x is equal to k from this, and then we expand this expression for different values of k as given here. Now we realize that since p is between 0 and 1, at some point this value will reduce to 0. So b is therefore the inverse of this in the brackets. Now in the second part, we are asked to find the expectation of x. This is the formula for expectation of x, and a simple substitution for f of x of k, which is this, gives us this, and this becomes a simple expansion for different values of k given here, where b is this value here. Similarly, for the expected value of x squared, we use the formula, which is this, and substitute for the probability density function, giving us this. Then we expand the summation, which gives us this, and at some point, like stated above, these values of p will decay to 0 because p is between 0 and 1. For the next part, we are asked to find the expected value of x squared minus expected value of x squared. So we just found the expected value of x squared in the part before, and the expected value of x in the other part. So it simply becomes a substitution, this here, and then the square of this value here. Again, we don't simplify it because there are other terms in between here and here, so we leave it in this form. For the other part, for the next part, we are asked to find the probability that x is equal to k, given that x is between 2 and 5. By definition, this therefore becomes the probability that x is equal to k and x is between 2 and 5 divided by the probability that x is between 2 and 5. From before, we know the probability that x is equal to k is given by this expression, and the probability that x is between 2 and 5 is this. We simply substitute into its formula for the different values of k, giving us this. And we also know from part A above that b is given by this function, and for p is equal to a third, substitute for p, and we get b is approximately 0.45. So therefore, substituting into this equation here, we can find the probability that x is between 2 and 5, which is this, which is about 0.545. Now, using these results, we can go back to this statement here, which is our main result for different values of k. So for k is less than 2, there's no intersection, and the probability is equal to 0. For k is equal to 2, the intersection is probability that x is equal to 2, which from up here you've already got as 0.3. So just substitute for that, and probability that x is between 2 and 5 is also already obtained, which is this, giving us this. And similarly, for the other values of k between 3 and 5, it's a similar procedure. And then for k is greater than 5, the probability is equal to 0, and therefore the probability mass, the conditional probability is given by this equation here.